Hi, in this video we will consider three main steps of scorecard development process in Plug & Score Modeler. First one is data preparation, second one is data analysis, and third one is directly modeling. So let's begin. Let's consider what the scorecard is. Scorecard is a table with a number of characteristics with points for each of them. To get the rate or score, we need to sum the weights of client's characteristics. Higher the score, the better the client and lower the risk. So we are going to develop a scorecard with Plug & Score Modeler. For this aim we need a data set. Let's load it. The data set is loading. In this data set should be presented a variable that we call target variable. This variable we are going to predict using other variables. Here in the top row there are names of variables that were automatically uploaded from the Excel file. We click OK and load in the data set. Clicking the next step. In this dialog box it is a possibility to choose what to do with anomalies, and now we will just disable records with anomalies because there are only 5 of them, and we finish this step. And now we can work with anomalies in detail if we need this. For example, we can show only anomalies here. As we told, there are only 5 of them. These rows are disabled. Here on the left we can see the number of categories for categorical variables, and here on the right we can see some histograms for both the variables. Here we click on finish processing, and we need to delete the disabled rows. It took some time, and in this window we have the whole data set, the whole process data set. Here we should select target variable. It should be a variable with only 2 categories, and in our case good category is a category with low credit risk. We should pay attention that Plug & Score Modeler automatically divides the whole data set to the 2 data sets, training one and validation one. Training one we will use to train our model, and validation will be used to test our model. Here we can manually assign the row to the validation subset or back to the training subset. Then we proceed to the variables tab. Here we have some statistics. IV means information value. Information value is a measure of predictive strength of the variable. So, if we sort the rows by IV, savings will be the most predictive variable, and home ownership will be the least predictive variable. All numerical variables have automatically been transformed to the categorical ones, but we need to correct this being. For example, let's have a look on the job time. For binning there are a few simple rules. There should be a maximum 5 different categories. It should be at least 5% of the subset in each category. We're trying to maximize IV. Here it is 0.79. It is a very predictive variable. And maybe the most important one, it should be a logical trend. Here is a rising logical trend, so it means that the client with great work experience, for example 5 years, last category, will be less risky than the client without any work experience. These two categories have about the same bad rate, so we can merge them. And now we have only 4 categories. Here we can move vertical A's or just place here and click on set value if we need, for example, an integer number. Now, when the correct binning for all the variables is done, we move forward to the tab Scorecard. The scorecard has been built automatically, and here we can see the scorecard points for each variable and each category. We can change the scorecard points in expert way. For example, it's necessary to renew the logical order, logical trend. More experience, the more points. So we place 132 instead of 152. Now we look on the characteristics. One of the main characteristics is Gini coefficient together with ROC curve. Here presented a Gini value for training and validation subsets. Gini coefficient, which is more than 0.6, means that the model is a very good classifier. There are also Kolmogorov-Smirnov curves with good result 64 and 68 on validation and training subsets, cumulative good versus bad rates, and important graph which shows good and bad distributions. Red one is plot distribution of bads and green plot of goods. Mean value for bad ones is 459 and mean value for good ones is 722. Here we can see the cutoff point. The clients with the score more than cutoff point will be classified as good, and if the score will be lower than the cutoff point, the client will be classified as bad. We move the cutoff point to 597. Let's have a look on the classification matrices with the cutoff point. We see that 84% of bads are correctly classified. This means that only 1 of 7 bads will be classified incorrectly. So we can conclude that this scorecard is quite precise. Let's look on the training and validation subsets separately. Here, training and validation one. We can see that classification correctness, code error matrix, changed insufficiently. This means that the scorecard is not only a good classifier, but also a stable classifier. So the scorecard is both good and stable classifier. These properties of scorecard are crucial. Now we can have a look on the scoring report tab. We can sort the rows by the score, and we can see that for the rows with low score we have a prediction bad, and for higher values of score, which are more than cutoff point 597, we have a prediction good category. Higher the score, the lower the risk. We can export this report if we need this by clicking on Export Table, or alternatively save our scorecard with points for each variable and each category both to the file and see source code. Here on the tab Risk Bands we can see the level of risk for each range. we need these bands to develop different credit policy for different risk categories of clients. So there are three main steps of scorecard development process: data preparation, data analysis and modeling. We will consider some more aspects of scorecard building in Plug and Score Modeler in next videos. Please contact us to receive a free trial version. If you have any questions about the system, please contact us sales@plugandscore.com or web plugandscore.com or by the phone on your screen. Thank you for your attention.